Hi, this is the continuation of analysis of sequential system 3, and we are dealing with timing analysis. And let's roll back and let's start the analysis from the beginning. So to find y for a milli machine, it is a good idea to have to find the consecutive states, I mean the queues of all the flip-flops. In this case, we've got two flip-flops and the initial values for them is assumed to be 0, 0, and they can only change the values on rising edges. That is here shown. And what the changes are results from this. This is the state tensor diagram. And how we do it. We read out this state and find it on the diagram. Then we read out x, which is when the rising edge occurs, the x is equal to 1, so we go along this arrow, so the next state is read out to be 0, 1. And during the next rising edge, you are here, and the input is 0, so you go along this. So the following state is 1, 0. Now you are in a 1, 0, and there is 1. When the next triggering edge occurs, 1 is aside this arrow, so you go to 1, 1. Okay. Then you can read out the value of y being in the consecutive states and looking at the arrows, the symbols aside it. Of course, x is also important, yes, because y can depend on x. In this case, in the 0, 0 state, y doesn't depend on x. In the two different values of x, y is 0. So you simply start with 0 on y. Then you move to 0, 1, look at this and this. For x1, y is 0. For x0, y is 1. So it is an inversion of, in this state, y is inversion of x. X is 1, so y is 0. X is 0, so y is 1 until the end of the state. The next state is 1, 0, so we must move here and read out the values aside the arrows. Independently of the x, y is simply in this state, y is always 1. So you maintain 1 until the next state. The next state starts from this edge and it is 1, 1 state. Read output is the same as x input, yes, and it simply follows x. Y follows x, x is equal 1, so y will be 1 as well. And this has finished our analysis. Thank you.